my adjacent one should be a positive root 3, and then my sine, my opposite value, should be a negative 1 right down here, and then my hypotenuse is going to be 2. Great, so if I look at this triangle, I can recognize that it is going to be a 30, 60, 90 triangle. I know that the angle that goes with 1 is going to be 30 degrees, which is right here. So I know that my theta has a reference angle of 30 degrees. However, this terminal side falls way down here, so that means I'm starting over here. I'm going to go around in a circle until I get to this side. That gives me 360 degrees minus 30 degrees, which is 330 degrees. So this is 330 degrees. Great, except that it gives me an interval. So 2 pi is going to be 360 degrees, and then I need my angle to fall in between 360 degrees and 720 degrees. Well, 330 degrees does not fall in between 360 and 720. So what I'm going to do to get my angle, to get an angle that's going to give me these values, is I'm just going to circle around twice. Okay, so if I start here, let's use a green pen. If I start here, I go around once, that's 330 degrees. If I go around a second time, I'm still at the same place, but my angle is twice as large. So if I go around a second time, so what that means is I'm taking 360 degrees and I'm adding 330 degrees to give me 690 degrees. So what is the measure of the angle? It's going to be 690 degrees. Now, since they give me my interval in radians, I'm going to take 690 degrees and I'm just going to turn it into radians. To turn it into radians, let's do it right here. Okay, 690 degrees, and then to turn 690 degrees into radians, I'm just going to multiply by pi over 180, and that's going to leave me with 690 pi over 180, and then I'm just going to simplify my fraction. So I'm going to chop off my zeros here, which gives me 69 over 18. And then I can simplify that, 69 pi over 18, and then I can simplify that even more. It comes out to be like, I don't even remember, sorry guys. But you can type it into your calculator and do it. I'm just going to move on. Great, so you can solve 2 and 3. Alright, let's look at number 4. An arc length of x is drawn on the unit circle shown below, and tangent of x equals w. Alright, the first piece of information I'm going to look at is this tangent of x equals w. Tan x equals w. Alright, well, w doesn't look like a fraction, and typically when I have SOHCAHTOA, I have these fractions. So what I'm going to do is I'm going to turn w into a fraction by putting w over 1. Great. Now if I think about tangent, I'm going to look up here at my TOA, and I know that tangent is opposite over adjacent. Okay, so what does that mean to me? That means that my opposite side is going to be w. W is just a symbol for a number, right? And then my adjacent side is going to be 1. So right here I've got my arc, and here's my point. So I know that my opposite, if right here is my point, here's my angle, and I know that my opposite is going to be w, and I know that my adjacent is going to be 1. Alright, there is my triangle. Now if I keep reading, it says, what is the value of pi plus x? Alright, so x is my angle here. Now I'm looking for my angle plus pi. Pi in degrees is 180 degrees. So I'm looking for my angle plus 180 degrees. So if I think about what 180 degrees is, 180 degrees is just a straight line. So if I'm up here, I'm just going to draw my straight line until I hit my other circle right here. And I have now just moved 180 degrees from where I started. Okay. All of my numbers stay the same. I'm just in a different quadrant. So I'm going to look now at this angle right down here. this angle that I just shaded and I'm drawing all over right now. And I'm going to match up my side. So this angle, the side across from it was W, so now this side right here, W. The side next to it was 1, this side is going to be 1. The last thing that I need to look at is if I go this direction, I now have a negative 1. And if I go this direction, I now have a negative W. So I have negative 1 and negative W. What is the value of pi plus x? Well, if I know that tangent of x is W, my new value, my new tangent of x is going to be negative W over negative 1. Alright, now let's go through the rest of them. Let's think about what that would mean for cosine. So cosine, oh, actually, just kidding. They don't give us enough information to solve for that. So I'm not even going to bother with it. Okay, let's move on to number 7, 8, and 9. Here's my triangle. This tells me that this is 60 degrees, so I know that this piece is going to be 30 degrees. And if I think about my pattern, I usually have 1 across from 30 degrees, 2 across from 90 degrees, and root 3 across from 60 degrees. So what I'm going to do instead of having these numbers is I'm going to replace them with x. So here I've got 1, so instead of 1 I'm going to put x. Here I've got 2, so instead of just 2 I'm going to put 2x. That's the same thing as saying 2 times 1. And then here I've got 1 times root 3, so now I'm going to say x times root 3. And this gives me 8, so I'm going to say 8 equals 2x to solve for my x value. So solve for x, that means that x is 4. So on this side, this length is going to be 4. Right here, this is going to be 4 root 3. And this is going to be 8 as it's given. Alright, now I'm going to look to find cosine of t. Here is t. Here's my angle that I'm looking at. Label all my sides. This is my opposite. This side across from 90 degrees is always my hypotenuse. And the side next to my 60 degrees is my adjacent. Alright, SOHCAHTOA. Cosine is going to be adjacent over hypotenuse. My adjacent value is 4. My hypotenuse is 8, so cosine is going to be 4 over 8. Sine is going to be opposite over hypotenuse. Opposite hypotenuse. Here's my opposite value, which is 4 root 3. And then my hypotenuse is still 8. And then lastly, I've got tangent of t, which is going to be opposite over adjacent, so that gives me 4 root 3 over my adjacent, which is 4. Now it says to simplify them completely, so I know 4 over 8 is the same thing as 1/2. I know that 4 root 3 over 8 is the same thing as 1 root 3 over 2, because I divided by 4 on both of them, which is going to be the same thing as root 3 over 2. And then here, if I look at tangent, I know that 4 divided by 4 is 1, which is going to be 1 root 3 over 1, which is the same thing as just root 3. Great. So now you should be able to do the second set of these that are on the next page. Now I'm going to solve for this function. So find the amplitude of this. These numbers are a little not clear, so it's 3, 6, 9, 12 right here, and then on the bottom it's pi, 2 pi, 3 pi, 4 pi, and so on. Alright, find the amplitude of the function. If I look at this function, my top value is 12, my bottom value is 0, so 12 plus 0 divided by 2 is 6. That's my 0 line right here is 6. So now I'm going to take 12 minus 6. 12 minus 6 gives me 6. So my amplitude is going to be 6. The period of the function, if I start right here, I go down and I come back up to where I started, I finish at 2 pi, so my period is 2 pi. My phase shift, if we're talking about a cosine graph, then I don't have a phase shift. So I'm going to call this a cosine graph. Now, if I think about my vertical function is where this 0 line is. So normally my 0 line is down here on the 0. However, this one starts at 6. So my vertical shift of my function is going to be 6. Now I'm going to fill in all my blanks. So I've got y equals a cosine bx minus h plus k. And I'm going to plug in my values. Y equals a, which is 6, cosine. I need to use my period to solve for my b, so I know that period equals 2 pi over b, and I know that my period is 2 pi, which is the same thing as 2 pi over 1, cross multiply, that's going to give me b is 1. So I can say cosine 1x minus h, but I don't have an h, right? My phase shift is 0, so now I'm going to jump right to my vertical shift, which is 6. Y equals 6 cosine x plus 6. Now it says write another function that represents the graph. So we already used cosine since I started here, so now I'm going to use a sine function. Alright, so sine always starts at my 0 line. So now if I'm looking at my 0 line, come down, come back up, and finish here. I keep the same period. Almost everything stays the same except my phase shift. Phase shift. Now I have to think about what my phase shift is. So I started here for my cosine, but now I'm starting here. This line right here is going to be pi over 2. Why? Because this is pi and this is halfway between, so I'm saying pi divided by 2 is where I'm starting. Okay, so my phase shift for this second graph, my h value is going to be pi over 2. Everything else is going to stay the same except my phase shift, and instead of using cosine, I'm now going to use sine. So here we go, y equals 6 sine, keep my same b value, x minus pi over 2 plus 6. And there is a new equation. Okay, and now let's do this last one. If sine of x equals 8 over 17, so I know that sine of x is 8 over 17. I'm going to write that sine is opposite over hypotenuse. What quadrant will the terminal side of x lie when it is placed in standard position? Alright, I have a positive opposite and I always have a positive hypotenuse. So a positive opposite is going to mean that I'm either up over here on this side or I'm on this side. Alright, this is where I always start. This is my starting point, which is, okay, right here is my starting point, and now my terminal side is going to be where my angle falls in terms of my quadrant. So now let's read this second piece of information. Cosine of x is less than 0. So cosine of x is less than 0. What does that mean? So that means that I'm going to have cosine of x equals adjacent over hypotenuse, but it's less than 0. Well, what kind of numbers are less than 0? Negative numbers. Great. So I know that my cosine is going to be a negative value. And since my hypotenuse is always positive, that means that I'm going to have an adjacent value that's negative. So if I look at this side, if I'm in quadrant 1, I am not going to have a negative adjacent side. I'm going to have a positive adjacent side. That only leaves me with quadrant 2. Well, let's look over here. If I go this way, will I have a negative adjacent side? Yes, I will. Great. So I'm now looking at quadrant 2. All of my angle is going to fall in quadrant 2. So now let's label it. So I know that my opposite side, here's my angle right here. And I know that my opposite side is going to be 8. And I know that my hypotenuse is going to be 17. And then this is my adjacent side right here. So to solve for my adjacent side, I'm going to do my Pythagorean theorem. So I have my hypotenuse squared equals a squared plus b squared. So 8 squared plus my adjacent side, adj squared. Alright, solve for your adjacent side. Your adjacent side is going to come out to be 15. There we go. adjacent 15, but remember it's negative 15.